Welcome to concavity and points of inflection. So first we're going to look at concavity and the second derivative. So if f double dash of x, meaning the second derivative is negative, the curve is concave down. If f double dash of x is positive, the curve is concave up. For point of inflection, if the second derivative is equal to 0 and concavity changes, then we have a point of inflection and you use a table of values to check. So using the second derivative to test a stationary point. So if we found a stationary point and the second derivative for that value of x is greater than 0, then it's concave up. If for that value of x the second derivative is less than 0, then it's concave down. If the second derivative equals to 0, so we have stationary point, so that was the first derivative 0, and the second derivative 0, then we go back to f dash of x to check if it's a stationary point of inflection. So let's have a look at an example. So we've got the curve y equals x to the 4 minus 4x cubed, and we're going to find the stationary points. We're going to determine their nature, but we're going to use our new method, which is the second derivative, find any points of inflections, and then finally we're going to sketch the curve. So we know that stationary points occur when y dash equals 0. So to differentiate, you get 4x cubed minus 12x squared. Take out a common factor and let it equal to 0. So therefore x is 0 and 3, and our stationary points are 0, 0 and 3 minus 27. So step 2, we're going to determine their nature, but this time we're going to use the second derivative. So when we differentiate a second time, we get 12x squared minus 24x. So for the stationary point, 3 minus 27, we take the x value, which is 3, and substitute it in. So when you put that into the second derivative, you get 36. That's greater than 0, so therefore it's concave up. For the stationary point 0, 0, we sub in when x is 0, and the second derivative is 0. So therefore we've got a stationary point that's also second derivative is 0. So we need to go back to our y dash table to double check. And when we sub it into the y dash table, so we pick our reminder, we've got our 0 is our stationary point, we pick a value either side. So on the left it's negative, on the right it's negative, so therefore it's a stationary point of inflection. Alright, part C, finding the points of inflection. Well, that's when the second derivative equals 0 and we need to check concavity through a table. So the second derivative, once again, was equal to 12x squared minus 24x. Take out the common factor and let it equal to 0, and we get x equals 0 or 2. But note that x equals 0, we've already shown, is a stationary point of inflection. So let's just double check the other point of inflection that we got when x was 2. Pick a number either side, and we get negative on the left, positive on the right, so concavity changes. So on the left we've got concave down, and on the right we've got concave up. So therefore that's a point of inflection. And there's the sketch of the curve. So you can see at 0, 0 we have a stationary point of inflection. At 3 minus 27 we have a minimum turning point, or where it's concave up. So notice down there it's pointing upwards on both sides. And at when x was 2 and y was minus 16, that's where our point of inflection is. Thank you.